This week we're going to be talking about direct and electronic ignition systems. Alright, so here we are. Again, we're on this '06 Suzuki Grand Vitara, and today we're looking at ignition systems. So here you can actually see we are a coil on plug system, and this is a 3-wire internally fired coil, and this runs down and actually makes contact with the spark plug that's down in there. And I'm going to talk about this 3-wire internally fired coil with a diagram in probably the next video here. So just to talk about some basics, the principle of the ignition system is to generate high enough voltage to be able to jump the spark plug gap. And from old to new systems, we're going to usually be doing that with an ignition coil. Now, how the ignition coil is grounded or controlled is completely different dependent on the system, but essentially they're all going to use a coil, and we're going to have a primary side and a secondary side, and we're going to have a coil wire wound around a metal core of some sort, but the primary side is going to have a lower amount of coil turns. The secondary side is going to have much more. The primary side having about 0.3 to 3 ohms of resistance, and the secondary side having anywhere from 8 to 15 ohms. But essentially, when that primary side is grounded, we're generating an electromagnetic field, and this is when this is grounded, this is called dwell, and we're saturating that coil. And once it's fully saturated, we're going to be able to unground it and collapse that magnetic field, creating a voltage spike. And that voltage spike is going to transfer over to the secondary side and be multiplied depending on the coil turn ratio. And then theoretically, we're going to have enough voltage to travel through the plug wire and jump the spark plug gap. Anyway, focusing on this system itself, this is a direct coil on plug system, so we're going to have a coil for each and every cylinder, and this one is actually internally ignited. So there's an igniter, or what basically acts as the ignition module, inside each coil pack. So all we got here is power, ground, and those are fed to each one of the coils, and then we're going to have a signal from the ECM talking to that igniter and telling it when it's going to actually ground that primary side of the coil. So the ECM itself is not grounding, it's just sending a signal to the igniter to do so. Also, because we have this piece of logic actually inside the coil itself, we're not going to be able to measure resistance on the primary or secondary side of this coil, and we won't be able to get picoscope waveforms for the primary and secondary. Alright guys, so here you can see we have the car running, and we're hooked up to one of these coils. We're probed in to read voltage on the signal wire to the coil, and then we have an amp clamp on the power wire. And this is an internally switched coil, so we're not really going to be able to look at primary or secondary waveforms, but we can see some of the current moving to the coil, and we can also see our signal where the PCM is commanding that firing mechanism in the coil to ground the primary side of the coil. So here, looking at our waveform, you can see the blue is the voltage on our signal, and the red is our amperage form. So you can see when that signal is commanded on, it grounds the primary side of the coil, and our amperage comes up, and it starts right when the PCM sends that signal to ground the primary. Right, so here we're actually looking at my '02 Silverado, and this it's a little dark, but this is actually the coil here, and this is a distributor system. So we have one coil for all the cylinders, and we have our connector here. This first pin is going to be power to both the coils in there, the primary side and secondary side. So it's a married coil. And then our white and black is our ground to the primary coil that is externally switched. And then there is a middle pin that's just a connection to the splice on the power for the secondary and primary. And then we have coming off our secondary winding to go to our distributor. So this we can actually measure the resistance of the primary and secondary winding, which we'll show here in a second. So we're going to go ahead and measure our primary winding resistance as well as our secondary winding resistance. So here we're going to go to our pins for the primary, and here we have 0.3, so that's gonna saturate pretty quick. Now if we measure our secondary windings, 6.02 kilo ohms, so about 6,000 ohms. So there you go. Alright, here we have a primary voltage waveform for my truck, and you can actually see that where that voltage begins to dip down, that's where the coil is actually beginning to saturate. And it comes back up. I think they're kind of adding some voltage on the ground maybe as variable dwell, so it's not fully saturated that whole time. Not really sure. But then you can see we have our voltage spike, and that's the spark actually jumping the gap. And then we have that little line after, and that's the burn line. That is the spark event, how long it's still occurring after it jumps the gap.